The question that we were working on for homework last night was the one that's up on the board right now. We wanted to find the tension in the rope that joined these two objects together. Now, we went through one of these questions as an example yesterday. You learned a recipe for solving these problems. That recipe involved a couple of different steps. What was the first step? Yep. Yeah, find the acceleration. So in other words, analyze the system. Do what you've done for more than a week here now. Analyze the system. Doesn't change anything yet. Analyze the system. Now, if we want to analyze the system, we're going to say F net is equal to the sum of the forces. That's all of these forces. FF plus, we'll call it FF1 and FF2 plus FA. Now, there is gravity and normal force acting, but they do cancel each other out because there's nothing else contributing or hurting the normal force. What mass do I use on the left-hand side here? F net is equal to m times a, but what is it, 12, 8, or 20? 20. We use the combined mass on the left-hand side. Now, if we needed a mass on the right-hand side, which I don't think we do in this case, but if we did, then we would use individual masses. Individual masses on the right side and total mass on the left-hand side. FF1, we're going to make negative 18. We include that because although it's acting just on the 18, okay, the force of friction on the 18 contributes to the motion of the system. So we're going to include that. Same with the force of friction acting on the 8 kilogram object. We're going to make that negative 12 newtons. And of course, the applied force of 45 newtons is acting directly on the 8, but that contributes to the motion of the whole thing as well. What we did not include there was the tension in the rope, because the tension in the rope doesn't contribute to the motion of the system. That's an internal force. It's not acting with the outside world. Friction, although it's acting on just one object or the other individually, it interacts with the outside world, not just what's in the back of the truck, basically. All right, so we're going to say 20 is equal to, 20 times A is equal to negative 30. That's going to be 15. So A is going to be equal to 0.75 meters per second squared. Is that right? Is that right? I think that's what we got. Now, what do we do once we have the acceleration? Yep, Jordan? Yeah, pick one object. Which one do you want to pick here, the 12 or the 8? Okay, so let's pick the 8 kilogram object, although we could pick the 12 as well. The 8 kilogram object has a force of 45 newtons acting on it to the right, and it has a force of friction of 12 newtons acting to the left. And it also has a force of tension acting on it to the left. The rope pulls back on it to the left. We'll call that Ft. And that's what we're trying to find here. So we'll say F net is equal to Ft plus FF2 plus Fa. FF2, or whatever you decided to call that force of friction. This time the mass that we use is not 20 kilograms. This time it's 8. But we're still using the total mass. It's just the total mass of our new free body diagram, right, Reed? Ft is what we're looking for. Ff is negative 12. Fa is negative 45. Sorry, positive 45. So what does that equal? Take the 12 over, becomes 20. I think it's negative 25, isn't it? Is it 27? Okay. Now, how many of you guys, when you calculated that tension force, analyzed the 8 kilogram object? Did you get negative 27 newtons? Or you did the 12, so you get positive 27 newtons? Okay, so remember that you're going to get the same answer either way, except that one will be a negative, one will be a positive. Negative here, because this 8 is pulled to the left by the rope. If you analyze the 12, it would be positive because that 12 is pulled to the right by the rope. All right? Okay, I'm going to give you a few minutes to work on this question that's on the board right now. It's essentially the same thing, except we've got an extra force in there. Ultimately, we want to do the same thing with this, and that is find the tension in the rope that joins object 1 with object 2. Just to correct a quick little mistake, guys, not the answer, but the method here. The net force, thanks to Liam here, Liam recognized that the net force is not 8, rather the net force is 8 times 0.75. Right? It's mass times the acceleration. Now, that gives me 6, Is that right? Yeah, is that right? Yeah. And then we take all the numbers to the other side, and I think we still do get, was it 27? Or negative 27 newtons. But Liam, you're absolutely right. We do need to include the acceleration there. And the people that gave me the answer had, I just didn't write it down, that's all. Okay, back to the question that you're working on here now, guys. We're going to take a look at this now. First thing we know to do is always what? Analyzing the, Reed, what are we going to do? What are we going to do first? Okay, FNet for what though? An object or a system? The whole system, right? We're going to need to find the acceleration of the system, so let's analyze the whole system, and we're going to do that by saying FNet is equal to the sum of the forces. That's F1 plus FF1 plus FF2 plus F2. So we got 4 forces acting this time. Not a big deal. Last question we had 3. It just means a little bit of extra work, not more difficult work. The net force is M times A. What mass do I use here? The 5, the 4, or 9? Read again. We're going to use the 9 kilogram mass. Good. So 9.0 times the acceleration is equal to F1, which we're going to make negative 20. FF1 is positive 7.5 plus positive 6.0 plus 5.0. Now, let's combine those numbers on the right-hand side. Negative 20 plus 7.5 plus 6 plus 5 gives me negative 1.5. And negative 1.5 divided by 9 is negative 0.166 meters per second squared. Why did I not round that number to the correct number of significant figures, 2 digits? Why did I leave it? Yep. It's not my final answer. Now I'm going to have to go analyze an individual object over here on the right-hand side. Which one do you want to do, the 5 or the 4? I think the 5 is a little bit easier because there's one less force acting on it here, but it's not much of a difference here. I'm going to pick the 5. We're going to say F1. F1 is 20. We're going to say FF1 is 7.5. And then we're going to say the force of tension. Force of tension is, well, whatever that is. So now we're going to say FNet, once again, is equal to the sum of the forces. F1 plus FT plus FF1. This time we're not including F2 because it's acting directly on the 4 kilogram object. And we are including that FT, which was the internal force before. Now it's not internal because we're analyzing one object. We're going to say 5 times, I'm not going to forget to put the acceleration this time, right? 5 times negative 0.16667. F1 is negative 20. FT is what we're looking for. And FF is positive 7.5. So let's take that number, 0.1667 times 5. We get negative 0.833. We're going to add 20 to that, and we're going to subtract 7.5 from that. And we end up getting 11.7 or 12 newtons. So negative 0.83 on this side, 12.5 on the right side, negative 12.5 on the right side. Take the negative 12.5 over by adding. Okay, does that make sense? How many people got that right? Okay, good. That's good. All right, what I'd like you to do now for the remainder of class and for homework over the weekend if you don't finish this is go back to the worksheet that I gave you. That's that 4-page worksheet booklet. And I would like you to find the tension or tensions, because some of them have 2 ropes. You may need to find the tension twice for 2 ropes for the following questions. Number 5, 7, 8, and 14. Now, there is good news here. You've already gone through this worksheet, and for each of these questions on this worksheet, you've already found what? The acceleration. So the first half of each question is already done, right? You've got the acceleration. You don't need to do that again. Just take that acceleration and now analyze an individual object within each system. Or in some cases, 2 individual objects separately if you need to find 2 tensions.